as our primary preference to this course. And as you know, we have been using embedded system a lot, and the idea now is to see how we can program them. So our agenda will be what you call definition of what is embedded system, their classification, and the application. So we'll be sharing good notes for that. And it's very important that you appreciate or understand the meaning of embedded system. Just a minute, as it is called.
Um, hear me? Can anybody hear me?
Yes, we
Yes, we
can.
can hear you.
Yes, we can hear you.
Okay.
So Anditi,
Yes.
you can hear me.
Yes, yes, I can.
Good, good. Sorry. I should have. I'll make you one of the admins so that you don't get stranded on the corridors of this Google Meet. So sorry for
Right.
that. So I was just warming up the class for you. So and I've just told them that you are coming in to take them through this bit of the hardcore, because you are the one in taking them through the hardware bit. And it's very important that um, they get a lot of technical exposure on this. So welcome on DT. So once you get now that you're in, I'll just exit Paul without making any noise.
Okay, I think that's an order, and I think maybe you can change my right so that I can be able to upload
Yeah, yeah. Oh, okay. Oh, in the classroom,
some of this.
on DT.
So the classroom folder, there's a classroom folder.
Uh-huh.
I think I can be able to. Let me just see if I can be able to drag and drop
Yeah,
and see if it's. Yeah, I think I can be able to.
yeah. This one I gave you the rights as a co-teacher. Maybe
Yeah, sure.
the meet is the one that I don't know where do I change the right now here meet. Let me see.
Okay, I think we'll be able to work on that. It's not
Yeah,
something.
it's not something urgent. We can
Yeah, can do it
uh,
later.
we can do it
So
later, right? Okay, fine.
yeah, so I believe the students can also be able to see this folder. Um, the CSC 327. Can any one of you confirm that you can be able to see the class folder?
In the classroom. Is it in the classroom? Yes, it's accessible.
So I can be able to see, I'm able to load the file. So can one of you confirm that you can see the class folders and you are able to see the class files?
I cannot see the files.
Mhm.
So
Okay, I've modified it.
is it the one with the course outline?
Yes, within the drive.
Yeah, and yeah, within the drive. Then there is projects, eh?
Yes, yes, yes.
Okay, okay, it's accessible. Mhm.
So I would want it to be accessible to the students and.
Okay.
So I don't know whether uh, the student can be able to see this. Anybody who can confirm that you can be able to see the folder?
I cannot see any folder in the classroom.
You still,
Sorry?
you still
I
can't.
cannot I cannot see any folder in the classroom.
Not yet uploaded.
Yeah, not yet.
Um, okay, but I've actually uploaded it. Let me see. Okay. Is it visible now?
Not yet.
Okay, because I've allowed, let me just modify this again to everybody to see. Um, can anyone check whether you can be able to? So can you see the? I've actually because I'd want you to have access to this this folder.
Not yet.
I believe you are supposed to get an email once you upload or share something. So we haven't gotten anything.
Mhm. share that. Okay. So have you confirmed whether you are able to see?
No folder yet.
Okay, so let me I'll work on it and ensure that it is visible on your classroom, because it is the folder whereby I will be able to post everything. And actually, I've been able to add a couple of files for you students to be able to use for the class. So I'll work on it, and I'll see exactly where the problem is. But I think I'll just need to begin the class, and before I do that, let me have a look at that. Okay, so so can you see my presentation?
Yes, you can.
Yes.
Okay. So initially I'd indicated that we will have a class project, and I'm sharing one of the things that I'm actually projecting right now is the class projects that I expect students to take during the period provided. So all the projects are listed here, and it will be upon you and upon your group. You'll have to make groups of 3. So you need to be 3 people per group. And within the 3 guys, you'll need to pick a project that you will do. And actually, you can see from my projected Word document what I expect students to go through. So I'll figure out how to be able to share this on your classroom, so that you are able to download this particular Word file and go through it and pick the subsequent topics that you would want or you would have interest in terms of the project work. So the project work has a few conditions, and the conditions are that you must be 3 of you. That is 1. 2, there must be a report submitted within the deadline period. So the project should be completed and done by Friday the 25th. This is May 2024. And there are the outlook on how we expect the project to come out. So you'll have to share a PDF file report, and not more than 6 pages, as instructions up there. And basically from the marks area towards the end here, you'll see how the report will be marked in terms of awarding of necessary marks. So once you get your group member, you must group yourself into 3. The minimum number of members per group can only be 2 and should not be more than 3. So that should be taken care of very, very carefully. So I'll need to make sure that this Excel sheet is editable by students, and you will be able to provide your details here, and you will put in your registration number within the project that you will do. So you can see number 1, we can have the registration number of our students who would want to do the project. You'll see where to put in the name. The next students will come in here. The next student will come in here. That is the 3rd student. So this other one, the last column here, should not be filled, because this is the area whereby we do not expect, I don't expect to have more than 4 people per given group. So I will only want to have 3 students in every group, and within that group, we should not exceed the required number of 3. So I don't expect anybody, any project list here. There are 30 of them. I do not expect to have students' names on the last 2 columns. That is column H and column I. So that should be well noted. So unless somebody have a question up to there in terms of what I expect the students to do in terms of the project and in terms of the report submission. Anybody with a question can ask. Yeah. So Mohammed Asaf Abdi, do you have a question?
No.
Edwin Aringo?
No, I don't have a question.
Fidel, do you have a question?
No.
Okay. So I think that is very clear, and I expect this to be very smooth from now onwards up to the 25th of May, when we shall actually organize for our presentations to start the following. I mean, the presentation will be within that week, but by the end of that particular week is when we'll have those particular documentation provided for marking. So having said that, I think we can begin this class. And I would want you to confirm whether you can be able to see my screen.
Yes, we can.
Okay. So as me and Dr. Mburu will take you through the embedded system and mobile programming course. So as the outline states, we will run this course from when the semester began, that is 4th of March, all the way up to the 31st. Thereafter, there will be an exam period between 4th and 16th. So the whole course objective at this particular juncture will be to develop a system in digital hardware systems. We will be able to create a mobile applications. And remember, from your project, you can see you have the C, you have the Arduino programming, and you have the Sketch. And Kotlin will be the language that I expect you to use when developing a mobile applications. So you need to note down those parameters. That Sketch will be one of the languages that you are allowed to use in terms of Arduino programming. Arduino programming language itself. You can also use C, and those are the only three languages that I expect to see on your project. And on mobile, as I've said, you will use Kotlin, because Kotlin is the language that is defined on this particular juncture as a learning programming language for mobile system development. So from that, we will also conduct analysis and analyze and interpret experiment using embedded systems. We will also integrate embedded and mobile devices for the purpose of solving the real-time problems. So this is not just a course, it is a course that will also be able to guide you and see how do we solve real-life problems using the embedded system setup. So that needs to be taken care of. So from there, now I think we can move to the next slide, whereby we would want to look at the introduction part of embedded system and mobile programming. We are going to look at some of the terminologies used, some application areas for embedded systems, and then we are going to look at the ARMs based processors. So on that, we're going to look at the fundamentals of ARMs processors, and thereafter we'll see a bit of the detailed part of that particular type of the microprocessor, type of processor that basically is utilized on Arduino or embedded microcontrollers. So to introduce this particular unit, we are going to look at the embedded system environment. And to look at the embedded system environment, more so as it turns out, it is just like a normal computer system architecture, whereby we have the central processing unit being the nerve center or being the brain of the entire system. We have the software arm of this particular environment. We have the output part of this particular environment. We have the actuators, which sits below. We have the sensors, which sit at the other side. All the actuators and the sensors these are external environments. So these are the things that basically will be utilized to give us an output. Remember, any system that has to be fed with some instructions must have a point in which you can be able to look at the output of what you fed into a system. So sensors and actuators will actually tell us once we put in these particular softwares to do a particular task, or a particular application is written to do a particular task, then how do we know that it's able to solve those particular tasks, or it's actually able to perform those tasks? So it is the sensors and it is the actuators that basically will be able to show us that the program I've written can be able to solve that particular problem. So that sits on the output environment. So within the CPU, the inside architectures, we have the memory. We are going to look at the memory of this particular environment, of this particular embedded systems. We have the AD conversions. We have the human interface interacting with the CPU. We have the diagnostic ports. We have the auxiliary ports. These are the power, the cooling, and so on. And then we have the ASIC ports. So these are specific components that we will see on the embedded system environment. So the beauty of the kind of notes that we are having here is that you will be able to have a few we will be able to have a few, what do you call it, links, so that you can read more on where we got this, we got this particular information. So there are some sources there that you can also be able to take your time and try and read more on this particular environment. So the domain of applications of the embedded systems. So embedded systems basically is made up of, it can have quite a wider domain. You can see we have the AI and the machine learning environment sitting within the embedded system domains. We have the smart health, we have the aerospace, we have the HCI, we have the robotics, the control systems, the virtual 3Ds, the infotainment systems, we have the smart systems. So NLPs all are within the embedded system. So you can see embedded systems is not only Arduinos. The Arduinos is just a software that can be able to write an application that can be able to work with all these parameters in terms of management, or in terms of integration, and also in terms of kind of, can I call it mechanized or control. So you also need to know that embedded system is quite a very interesting field, and it's used in several areas of the current technologies that we are seeing. Embedded system is key in all these parameters that you can be able to see in there. So embedded systems, basically, as we had initially stated, that what we are going to do as per the core, as the objective of this particular course, we will look at the Arduinos as the key component that we will be able to use to implement the embedded system devices. And we can also use the Raspberry Pi, but either of the two is welcomed. So if you are interested maybe to do your project with Arduino, fair enough. The problem that we had when we were doing crafting out this course is that the Raspberry Pis were not very flexible in terms of simulation. So that's why you'd see we are not so much into it. But if you're comfortable with the Raspberry Pis and you'd want to do a physical embedded system implementation, that within the department we have a few you can be able to borrow and run with it. So this is just a setup of how a simple embedded systems with Arduino is implemented. You can be able to see on this diagram, we have the cables that connects the Arduino microcontroller, the UNO Arduino microcontroller with other components. So we can have the display here, we can have some few sensors here and there that can be able to be utilized in terms of implementation of Arduino-based system. And if you look on this other side, we also have a Raspberry Pi. So this is a Raspberry Pi, and then the Raspberry Pi, it has a USB port. Actually, Raspberry Pi is basically an entire system. It's a complete embedded system. You don't need to add many things, but you can also be able to control it or use it as a PC. So you can program a few things within it, and it can be able to run on its own as a PC. So as much as the reason why we prefer Arduino mostly, because Arduino is a hands-on. You'll be able to add literally everything on it, and then you'll be able to control it from the human interface, and you'll be able to work with the relevant software to be able to allow it to work. So you can be able to see what's the difference between the Arduino system and the Raspberry Pi. So the Arduino system is much more of hands-on. You'll be able to add quite a lot in it for it to work. But the Raspberry Pi has already it's already made in such a way that there are some components which are already on board. So you just add a few to be able to implement a working embedded system. So you should also be able to differentiate. If I would be able to ask you what's the difference between an embedded system implemented using Arduino and embedded system implemented using a Raspberry Pi, you should be able to have a few differences and a few similarities. So embedded systems with Arduino, basically it's something like this one. You can see I have my my UNO or my Arduino microcontroller sitting in here, and I have a component on the other side. So the component can display, and you can be able to program it so that it displays maybe a specific number or give you a specific output. So that's one of the examples of embedded system using Arduino. So embedded system with the Raspberry Pi, we would want also to look at a few components that are found within the Raspberry Pi environment. So within the Raspberry Pi environment, you can be able to see we have the board here, and Raspberry Pi is made up of 4 pins. Headers. It has quad USB ports for connecting maybe mouse, keyboard, or even powering this particular board. It even comes with an Ethernet socket, which is base 10/100 base T, meaning that it can max send data at 100 megabytes per second. Then we have the display, the DSI display connector. So if you would want to have this connected maybe to a screen or to a monitor that you can be able to see what you're doing within this particular board. It has a secondary storage at the bottom here. The micro SD card can be slotted in here, and you can be able to even install operating system on this particular board, and that operating system can just be utilized like any other operating system that you have on your machine. It has also a 5-volt micro USB. So this basically is for powering this particular board. So you can power your board using this micro USB port. It has HDMI port sitting down below next to the USB 5-volt micro ports. We have you can be able to do a camera here. You can be able to connect your camera on this CSI camera connector. It has a jack for the audio. So if it is something that you are programming to produce a specific audio, then this is a component that you can be able to have a jack fixed in here, and at the end of the day, it can be able to play some sound using that particular port. So we had seen that we also need to introduce the component of the microprocessor or the processor family that is being used within the Arduinos and the Raspberry Pi boards. So in this area, we are going to use the microprocessor basically being used in this particular component. Like on your PCs or on your desktop, you have the AMDs, you have the Intel microprocessor, you have the Cyrix, the Xeon microprocessors on the servers, and so on. So when it comes to the reduced technology, whereby we have embedded systems was one of them, we will have the ARM Cortex microprocessors that are utilized to implement this particular embedded system. So the Cortex processors is made up of several components. So we have Cortex M0, we have Cortex M3, M4, and M7. In terms of like, you can have the microprocessors, you can have the dual cores, you have the Core i3s, you have the Core i5s, and you have the Core i7. So in the microprocessor being used within the embedded systems, we use what we call the Cortex as one of the the ARM Cortex M series are being utilized to implement the brain or the microprocessor for the embedded system, more so on Arduino and on Raspberry Pi. So you can look at the architecture of this. The architecture is relatively the same as the architecture we have on the ordinary microprocessor that we use within our computers, that we use within our desktops and our servers and so on. So this is actually the layout of how the ARM processor family is designed. So within that particular context, you can go further and try to look at the ARM context
Did something happen? Ama class ilisha? Or Onditi, are you here?
I think ametoka. Simuoni kwa list of contributors kwa meeting.
Okay. Okay.
Maybe ameenda offline na ajui.
No.
Yeah, someone call him. Asikuwe anajiongelesha kwa nini yake. Kidhani ana present.
First, I'm deleting
application, and I'm trying to fight with
Okay.
components to be able to get back to class.
Okay. Sorry for that. Actually, I got a call that they have been waiting.
Yeah,
I hope now it's your net is stable.
Yeah, I've fixed it. There are some power fluctuations, and I didn't know the main internet source went down.
Okay. Okay. No problem. Okay.
Okay, so I think we can be able to continue from where we were. Okay, so let me just go back to the slides. So where did you lose me? I would want just to get in there. We picked up this. Can anybody hear me?
Yes, was applications, real times, and microcontroller, that image. Was that separation?
This one here.
No.
Sorry?
No, it's not that one. There was one where it was describing ARM. So there's the applications, real time, where there are 3 separations. Yes.
Okay. We looked at that. I hope by this time we're still together. We covered everything on mobile applications.
Just scroll. I'll tell you where I lost you myself. So it's not that. I don't believe you talked about anything about a smart home.
Wow, then you lost me.
We just lost you like 15 minutes into the class. Yeah, there. Yeah, just down.
We're there.
Wow.
Down the next slide, yes.
Interesting. I've been talking with myself for quite some time. Sorry for that. I think I just lost.
Slide after that one.
Yeah, I think I lost it quite some time. I've been like talking to myself for.
Yes, that's the slide. Application processors, real time, and
okay. Yeah, so I think let's just begin from here, and I think we just need to move a bit faster because time is not now on our side. So as I was saying, that embedded systems has quite a number of, it does have an architecture like any other PC or any other computer system. And as I was saying, that the ARM is the microprocessor in this case. Like for example, you have the Intel Core i3, Core i5, Core i7. In these scenarios, we have what we call the ARM Cortex, M versions or M profiles that will be able to define the architecture of the processor that actually is being utilized on the microcontrollers that are actually the core or the engine of embedded systems. So the ARM Cortex profile is basically made up of the application processor. It has the real-time processor, and actually it has also what we refer to as the microcontroller. So a scenario whereby we have those 3 parameters running side by side, then basically we have what we call a Cortex processor that can be able to control an embedded system. So having said that, then I went down here and then introduced what you call the mobile application programming environment. So the mobile application programming environment is whereby you would be able to write a specific code that would be able to do a specific task, and that particular being interfaced on your phone and then your phone also being interfaced with your embedded system and can be able to do a specific controls within your real-time environment. So within the mobile phone application programming, the environment is such a way that you'll have the backend application running somewhere, and you'd also have what we call the communication channels that you'll be able to use to connect between your backend environment and your front-end environment. So you'll have the mobile service, you'll have a wireless connectivity, and basically you can also have the internet connectivity that will be able to interface you between the front end and the back end. And then you'll also be able to have the embedded system running in another environment. So whatever that you shall have written or set up on your backend can be able to be sent or be able to be utilized to control a specific embedded system. Having seen that, you'd also need to look at several languages that you would be able to use to program and a device that can be able to control the embedded systems. And these are the basic languages that each one of you knows: the JavaScripting, the Pythons, the Cs, the Swifts, the Kotlin that we think or we feel is the best for this particular class. So most of you need to put your hand on Kotlin so that you understand basically how is Kotlin utilized to implement a mobile application that can be interfaced with the embedded system. So having said that, we really need to define what embedded system is. So one of the things that you really need to know is that embedded systems are computer systems which particularly defines functions within other larger mechanical or electrical systems. So you have a mechanical system, you have an electrical system that you'd want to be controlled with a computer system. So you'd be able to develop an embedded system that will have instructions when executed, then you'd be able to do control an electrical system or a larger mechanical systems. So they control many devices we commonly use. So and one of the advantage of the embedded systems is that they consume low power, and they are small in size, and also they are not very costly. So you'd also need to know that these particular embedded systems, they are not of very high cost. So within the embedded system, there's what we call the microcontrollers. So microcontrollers are small computers on a single integrated circuits. This is just the ICs with contain a microprocessor, it contains the memories, and actually it contains the programmable input and output peripherals. So these are the peripherals that you can be able to display, and actually you can be able to use them to interface so that you program and actually have your microcontroller executing a specific task. So that is part of that. And also, you also need to understand that embedded systems is dedicated to perform a specific task. It doesn't do everything. You must just tell it, I want you to do this, and that is what it will actually do. So it can be optimized to reduce the size and the cost of production and increase reliability and performance of that particular production. So if you're doing mass production and you want something that would be able to automate and ensure that everything runs as scheduled, then one of the systems that can be introduced is what we refer to as the embedded system. So embedded system is every gadget in terms of technology rollout. So whatever you use today, your phones, your smartwatches, washing machines at home, the scanners, the printers, the security systems, the elevators, the ATMs, the vendor machines, the GPS for locations, the traffic lights that we see today in Nairobi and the big cities within the world, the remote controls, the microwaves, all this, there's an aspect of embedded system implemented on them. So they use embedded systems actually in virtually almost everything today in terms of technology growth. So almost all the devices that you're utilizing or you're manipulating or controlling, there's an aspect of embedded system. So we can also comfortably say that embedded system is part of the IoT. So this is a technology in which objects, animals, or people are provided with the unique identifiers and the ability to transfer data over network without requiring human to human or human to computer interactions. So you can see the power of IoT is also fueled by the embedded systems. Your smartphone still sits on the embedded systems environment. So you can look at your smart home, and within the smart home, you have the locks control, you have the security, you have the blinders that can be able to control the amount of lights that get into the house and get out, the temperature of the rooms, the lighting systems, the application, the irrigation of the plants outside, and apart from the plants, the irrigation of the grass and so on. So you can be able to see most of the times embedded. Any question up to there? I hope you can hear me. You have not lost.
Yes, we can hear you.
Yes, I can hear.
So, do anybody have a question? So, what is embedded system? So, embedded system is actually picked from two words, the embedded and the systems, which embedded means hidden inside so one can't see it. Again, system means multiple components interfaced together for a common purpose. So, embedded means it is hidden somewhere, and it's hidden, but it is connected to other things that actually can be used to manipulate it so that it gives you an output. That is just an image of an embedded system. And embedded to fix an object family and deploy in a surrounding mass, or had an operation to remove a nail embedded in his chest. So you really need to understand the word embedded properly, so that once you come across the implementation of a device or equipment which is enhanced using an embedded system, then you can closely understand what embedded system is. So you can see, to insert a media file such as graphics, video, audio into a computer document, you can say you're embedding. So basically, in these particular slides, you really need to understand what does the word embed means in terms of systems. A system is just a thing in an environment that has a goal, consists of parts that are interconnected, and each part contributes to a specific goal. Just like the human parts, you can see we have several body parts which can work together to be able to make the human being who the human being is. So embedded system architecture is basically this. You can see a gateway there, and you can see a user interface, which is the fingerprints, the sensor, the keypads, the switch. We have the input variables, we have the output variables, and then we have the embedded. So the embedded computer here is the software and the hardware. And from the structure there, then you can be able to pick that out. So do we have a question? In terms of what embedded systems are? Alex, any question?
Nope, I don't have any currently.
Shem? Emmanuel Shem, are you here with us?
Yes, I have no questions. Thank you.
Okay. Let me have a look at this. Adrian Bikuri, any question?
No questions.
Let me go down here and see. Ian, Maina, Mururi.
Yeah. I don't have any question.
Does this thing make sense?
Yes, it does.
Okay, Gloria.
No questions so far.
No questions so far. Dominic, Kimeu.
No questions.
Okay, so I need to look at a bit of the programming, mobile programming aspect, and see. I'm just going to do a bit of introduction, and then we'll need to pick from here in our next class. So how do we interface basically the mobile and the embedded systems? Mobile development. So mobile application development is the act of process or a process by which a mobile application is developed for mobile device such as for personal digital assistance, enterprise digital assistance, or mobile phones. So the software applications are designed to run on our mobile devices, such as the tablets and the smartphones. The applications can be pre-installed on phones by the manufacturers or delivered by the web application using server-side or client-side processor, and what we refer to as application-like experience within a web browser. And this is something that most of you have been doing. You're able to download application and then update them on your phones. So it makes up of so many things. The mobile environment. And the other thing that comes in with the mobile programming is what we call cross programming or cross-platform mobile development, whereby you'd be able to borrow from specific application and put it together with this other application, and you have one application running as a unit. So on mobile application, you really need to understand what is cross-platform. You can have a look at that. Having several applications that can run in several environments. Cross-platform means an application can be picked by the iPhone extensions, the Android extensions, the BlackBerry extensions, the Microsoft, and the HTML5 extension. So you have one application, but can be able to be consumed by several devices. Okay. We need to start on microcontrollers. I think this class has not gone very comfortably because of the hitch that we've had. And I would want, if there is no any other question, I would want to stop in here so that in our next class, we would want to introduce the microprocessor or the microcontrollers that are basically implemented on the Arduino boards. And we see quite a number of components which will also help us when it comes to the implementation of microprocessor on the simulators. So one of the things that I would want you to do on your end, I would want you to initiate or start learning about the Tinkercad simulator. As I told you in our introductory class, you need to look at the Tinkercad and see how do we implement the embedded systems or automate embedded systems using Arduino on a Tinkercad simulation environment. So I would want you to take some time and look at your Tinkercad and see how would you use it to implement the Arduino solutions. So I will share with you the two documents. That is these notes. I will also share the Excel sheet that is here, and I will also share the project documentation so that you have a look at it, you fill them up, and then you need to start looking at what you are interested in and what you can be able to do. So I would want to stop in there unless somebody has a question from your end.
I have a question, sir.
So Hassan, go first. If you have a question.
Will tomorrow's class be online or physical?
It will be online.